Hi everyone. In the previous lecture, I have created the config server repository, and now I can create the config server microservice that will fetch the data from the config server repository. Let's create a new module called config server. And add appconfig data and Spring Cloud config server along with Spring Boot autoconfigure dependencies. For Spring Cloud config server, we will get the dependency from the Maven repository for 2.2.6 release version and add it to our pom.xml file. At this point, to be able to work with Spring Cloud, we also need to define Spring Cloud dependencies with version Hoxton SR9. And then define the Spring Cloud dependencies with type pom and scope import on the dependency management section of main pom.xml file. We also need Spring Boot autoconfigure dependency to be able to use Spring Boot application annotation on the service itself. Because just having the Spring Boot application annotation is enough in this module, which will help me to create a runnable Spring Boot application. So I don't add the Spring Boot starter module, which will add more than the required dependencies. Instead, I add the autoconfigure dependency here, which will add only the required dependency for this module. Let's also create an application YAML file and set server port as 8888. And also set logging level to info for root. And to debug for Spring Framework Cloud Config. Because when we first run the config server, we want to see what's happening under the hood for config server. With debug level, I can see all the details about the config server in the log output. So here in the application configuration file, I am overriding the logging level that is already defined in the logpack.xml file. We also need to create a bootstrap YAML file here. And add Spring application name and Spring Cloud config server git URI for config server. As you see, I set the file path of the config server repository in this URI definition. This bootstrap YAML file is loaded by a parent Spring application context, so it will be loaded before application YAML file. And for the Spring Cloud, we need to set bootstrap phase configurations in this file, because this bootstrap YAML file will be used to obtain the application configuration from the config server repository prior to loading application YAML file. Bootstrap phase has priority over application YAML file, and Spring Cloud config server need to use bootstrap phase first. So I need to separate the two configurations, bootstrap and application. And that is the reason of putting the Spring Cloud config server URI property in the bootstrap YAML file. If we check the URI, we see that we are using a local file system, which shows the newly created repository in the previous lecture. Although this is a good start, as we don't need to install a Git server locally, it is actually shouldn't be the preferred way. Because with a local file system, the configuration data will not be cloned by the config server, and instead it will work directly on the file system. And when it comes to high availability, we need to point all config server instances to the same repository, So with a file system, only a shared file system will work then. But even with a shared file system, config server cannot clone and cache the config data in this scenario. If we want to use cloning and caching, we can change the protocol to SSH for local file system, and then use a local Git server so that caching could be in place. But in our examples, in the end, we will be using a remote private GitHub repository for holding configuration data, which will be easier to manage and scale. Here we also set clone on start as true. That means configuration server clone the config server repository on the startup. And also we will set the fail fast true. That means if config server cannot reach the config server repository and load the configuration, it will stop immediately. Let's finally create the config server application class. First, we will create com microservices demo config server package, and then create the class config server. We will annotate this class with Spring Boot application annotation, as well as the new annotation enable config server. This will mark this class as a config server by Spring Boot. Then, as we did in our previous microservice, we will just call the Spring application run method in the static void main method. And for the run method, we will pass config server class and arguments as the parameter. Now this Spring Boot application is ready to serve as a config server. Alright, I will see you in the next lecture.